All right. I wanted to do hopefully not a really long video here, but a short video. I want to review. I saw a really cool article. It's about a 7-page article today, and it's a review of the order of operations. The myth and the math was the name of the title. Um, Recently stumbled across it. It was a short article. It's by Jennifer M. Bay Williams and Sherry L. Martini, I believe. It's copyrighted 2015 by the National Council of Teachers of Mathematics, Incorporated, and I've got the website listed there. Maybe I'll try to put a link in the description when I do the video. I found a copy online and I read through it, and it was a pretty fascinating 7-page article. And I would suggest looking at it if you want to get some more information on order of operations. Um, it covered 6 main topics. I'm going to look into some of those here. And it kind of looked at each one and tried to determine whether each topic was a myth or an actual part of mathematics. So basically, myth or math. And I guess if you're in the UK, you would say maths. I'm constantly reminded of that, which is fine. Um, Without permission, I don't have permission, so I can't really reproduce it here. I'm not going to do that. I will kind of, in general, discuss it. We'll say that it does go after some myths and order of operations about how, in some ways, it's sometimes taught as being very rigid, or it's considered a very rigid standard. And it's also a myth that it was designed in some sort of arbitrary fashion, that somebody just decided, hey, this is what I want, this is what makes sense to me, and we're going to do it this way. Because that's one of the arguments I see a lot from people is they're like, well, why did they make up this silly convention? Like when I read a book, I read left to right. So why don't I just do all mathematics left to right? I don't care about things like whether it's addition, subtraction, multiplication, or division. Just do it left to right. People make that mistake and they don't really know the deeper reasons for why order of operations is what it is. And a lot of people will say that, well, order of operations, it hasn't changed since the 16th century, where, in fact, it actually has somewhat. The foundations were set back in the 16th century. You can go back and find, some of the early texts, early books on algebra. Order of operations came up. You've got things, exponents were introduced sometime. I don't recall exactly. It might have been the 17th century. I don't remember. But there's some debate that still remain in order of operations, and that debate is probably out. You can go out about 100 years and see where there were some debate. Now I've seen textbooks from I think the late 1800s. I've seen one I know of from the 1913 that was fairly clear on the order of multiplication and addition. Um, with as textbooks started to increase in their use in the early 20th century, I think the standards came into better shape. I mean, depending on who was writing the textbook, and I think that's probably a lot of it. I don't know for sure, but I'm assuming that, back then you didn't have the plethora of books and publishers you do now. And so there probably were people that were writing things that just didn't jive with what order of operations should be. There were some books, even in the early 1920s, that, mentioned there wasn't really a consensus between, the precedence of multiplication and division. However, I can find, books earlier than that that did. So, take that for what it is. But the order of operations is far from arbitrary. I've seen people try to argue this left to right thing, and all mathematical operations should be done from left to right without regard to order. You don't care about precedence, which that's kind of simplistic thinking. It's really flawed. And best way to look at that would be to take an example and say, if you have an example here like 6 plus 9 times 3, okay, we understand that multiplication is simply repeated addition. In other words, multiplication is like a shorthand. Like, you've got, was it stenographers or the people that take notes in a courtroom, they know shorthand. They're basically typing, or it used to be writing on a tablet, I guess, the conversations in a courtroom, and they were keeping track of that using shorthand. Well, you got to think of multiplication in the same manner. Multiplication is shorthand for addition. It's an easier way of writing it out. You know, you can replace the multiplication in this problem with the equivalent addition. So instead of 6 plus 9 times 3, you can make it 6 plus 9 plus 9 plus 9 equals 33. So whether you leave it alone or whether you add, put it in, you replace the multiplication, you're going to get the same answer, basically, because multiplication already has precedence over addition. And that's one of the things a lot of people mess up. They think that everything is the same and you go left to right, but multiplication, and the same thing with division. Division is considered to have equal precedence with multiplication. So, multiplication should be done before addition. And that goes for subtraction too, but we'll get into that more later. Um, and you also realize that you can take that problem and say 9 times 3 plus 6 is the same thing as 6 plus 9 times 3, because you're still multiplying the 9 by 3 and adding 6. However, if you change the problem to 6 times 9 plus 3, well, obviously that's not equivalent, right? 6 times 9 plus 3 is not 33. So you can't just swap the operations themselves between the numbers. You won't get the same answer. So when you look at this is a lot of the basis for why multiplication has precedence over addition and subtraction. Um, so the nice thing about this article that I read about order of operations is that it explains why it's important to understand why order of operations is made the way that it is. One of the most disturbing parts of order of operations is how it's perceived as some kind of rigid structure. It's possible to look at a problem, and if you understand the order of operations, and you understand things like the distributive or associative properties, you can simplify the problem in a way that you're still honoring the order of operations. So what I mean by that is a lot of people get stuck in this, rigid thing of like the 4 steps, parentheses, exponents, multiplication, division, addition, subtraction, so on. But they lose sight of the fact that you can simplify a problem in a way that doesn't mess with order of operations, but it's maybe a more efficient way for you to solve it. So here's another example of, let me try to explain that through an example. Um, You've got 4 to the third power plus 6 times 12 plus 13 times 2. So if you're taking a rigid order of operations approach, they would say to simplify the exponents first. And so if you use the PEMDAS system, now, and you hold on here, I understand there's BODMAS, BEDMAS, BIDMAS, PEDMAS, whatever you want to call them. I'm gonna use PEMDAS here. They're all the same. They're different 6-letter acronyms, but they all represent the same 4 steps of order of operations. It's whether you call parentheses brackets or whether you call exponents indices, I believe, for BIDMAS, and I think order uh, for BODMAS. I think is how it is. BEDMAS, I believe they're still saying exponents. It's really just the terminology that's the same thing. Anyhow, I'm getting way off track, but so if you're using the strict format and you're looking at parentheses, exponents, and then multiplication or division, addition or subtraction, okay, you start with the exponents 4 to the third power, 64. Then you go down the list and you go, okay, multiplication's next because I already done the exponents. So 6 times 12 is 72. Then you've got another multiplication. 13 times 2 is 26. And then finally, you add from left to right. 64 plus 72 plus 26 is 162. But now, if you understand how to simplify this problem properly, you can simplify sections that are going to be later added together. It's not going to harm anything. So there's no reason to not look for an efficient way to solve it as long as you know what the order of operations is and you understand that exponents have to be resolved before the multiplication. I can't go and add 4 plus 3 or 4 plus 6, from the original problem. It's got to be 4 times 4 times 4, 4 to the third power, 4 cubed, okay? Um, so looking at that same problem again, since we know that the results of the multiplications are going to be added last, it doesn't change anything to solve them first and just keep track. So I can say 6 times 12 is, the 72. Right, I don't know if my mouse even shows up here, but 72. And then you can do the 13 times 2 is 26. Now you can go back and you can solve 4 cubed. 4 cubed is 64. And then you can go 64 plus 72 plus 26 is 162. And so what you got to understand is solving this way does not violate the order of operations. It's good practice to look for efficient means to solve it. It stimulates your mind and helps you like think more about the order of operations, how it really works. So, rather than being locked in some meaningless order and rather than just simply memorizing, some six-letter acronym, and then assuming it's some sort of a checklist, and then um, you know, when I say this, some people start raising their eyebrows because they think that I'm trying to say mathematics is subjective and you can solve any way you want. That's not what I'm saying. I'm saying you can't violate the convention, you can't violate the rules, but you can solve it efficiently knowing in your mind how order of operations works. And so what I find is a lot of people will memorize the acronyms or, whatever, but they don't really understand order of operations. And I think that's really harming a lot of people. Yeah, I want to get into the next thing here. Basically, I call this section the garbage of PEMDAS, and I can see people screaming already, probably throwing their keyboards or their mouse. But hear me out on this, okay? And please don't go back to a forum and say, look, this guy on the internet told me that PEMDAS is garbage, and then so I can just solve everything left to right. Yeah, don't do that. Okay, I'm not telling you that. But one of the most aggravating aspects of trying to convey this order of operations is the reliance on these terrible memorization tools, and I do call them terrible, such as PEMDAS. For a long time, students have been made to memorize the mnemonic, please excuse my dear Aunt Sally, which is a mnemonic. Um, PEMDAS and Sally are just a couple of memorization triggers that are popular in the United States. But, if you travel to other English-speaking countries, you'll see BODMAS or BEDMAS or maybe BIDMAS. And all of these acronyms lead to the assumption by many that the order of operations consists of 6 steps. People misinterpret it. 6 letters does not mean 6 steps. There's only 4. And too many adults today assume that multiplication has a higher precedence than division. Okay, I see that I typed that wrong. But some people, especially the PEMDAS people, will say that multiplication has a higher precedence than division because PEMD. That's wrong. The same misconceptions are made of people that understand BODMAS. There's students in the UK that might believe that division has a higher order of operations than multiplication, because the D comes before the M. You could write it bombed us if you wanted to, but that's not true. So now before you assume that order of operations is garbage, because the memorization tools are garbage, you first need to understand that no matter what acronym you're using, the order of operations has 4 steps, okay? Number 1 would be parentheses. I believe in the UK and other English-speaking countries, they're going to refer to it as brackets, okay? So you either got parentheses or brackets. Number two is exponents. Now, with BODMAS, that's order. Now, I have to stop for 1 second because I've seen a lot of people say brackets of division, multiplication, addition, subtraction. Where are they getting of? And I mean OF, the word of. It's order. I mean, I'm not from the UK, but I understand that. But I've seen lots and lots of people say brackets of division. That's how they start to say it. I don't know where that comes from. Maybe somebody can post that in the comments. I'm just really curious where some of these crazy things come from. I know it's order. And then a BIDMAS, it's I think indices, I believe, INDICES, I think is what they refer to it. You can correct me on that. That's not one that I use, but okay. So you got parentheses, exponents, and step number three is multiplication or division left to right. So when you're encountering that, you basically can go left to right. We're going to get into that one a little bit more too, because there's some interesting things about multiplication and division. They're the same thing, though, basically. Division is just multiplying by the reciprocal of a number, right? You can say 10 divided by 5, or you can say 10 times 1/5. It's the same thing. So think of multiplication and division as basically the same operation. Then you have addition or subtraction left to right. So addition and subtraction, once more, they have the same level of precedence. And the one's not before the other. It doesn't matter, honestly, if you add or subtract first in a problem. You're gonna, and we'll see that, but in other videos. But think of subtraction as the addition of a negative number. So addition and subtraction are really the same thing. Yeah, I think here I mentioned in Canada and the UK, BODMAS is widely used, brackets, order, division, multiplication, addition, subtraction. So same thing. Um, and another thing that I need to really focus on here is this misconception about parentheses. I spent a little bit of time in some forums, in some of these online puzzle things where I'm trying to help people. It's really hard sometimes because of the ingrained beliefs that some people have. And one of the big ones is this misconceptions of parentheses. I cannot tell you how many people have said, well, there's no parentheses in this problem, so you just solve left to right. Their assumption is you just toss the order of operations out the window. And I don't know if that's a result of people memorizing PEMDAS or BODMAS and then thinking, well, if you take off the first letter, you throw the rest of the letters away. I really don't know where that got started. I would love if somebody ever finds like an in-depth analysis of that. I'm just really curious about the psychology behind that or what brings that about. I don't know how that myth got started. But one thing I did find that was really interesting as I read this particular article, published back and copyrighted back in 2015, is that article references another one from an author, Mies. I'm not sure I have the name right, but that's from 2011. And the suggestion there was a better approach to understanding order of operations would be to first understand that there's only three operation symbols. So when you talk about order of operations, you got the 6 letters of the acronym. Truly we're talking about 4 steps, right? You got brackets, order, multiplication, division, addition, subtraction being the fourth step. But parentheses, or if you call them brackets, they're only grouping symbols. Parentheses are not an operation. It's not an operation. So the interesting thing in this other article was that they like to use a graphical pyramid. Now you'd have to look up the book. I'm not going to put it here because I don't want to copy the pyramid, but basically I use a pyramid that shows the parentheses outside of the pyramid with a note indicating, hey, you've got to do all the operations within the parentheses first. And then after that, you've only got 3 steps in the pyramid, the top one being exponents, your next one being multiplication or division, then addition or subtraction. Um, and yeah, many times the people will get confused and they assume things like they'll assume that multiplication precedes division. So, look at this problem here, 80 divided by 5 times 8. If you did do the multiplication first, you're going to get an incorrect answer of 2. The correct answer here is 128. You basically, you go left to right the way that it's done in the US and most places. You go left to right, 80 divided by 5, and you take that result times 8, you should get 128. Um, another interesting part of this article, which I didn't know honestly until I read this, order of operations. A lot of people say it's universal, it's worldwide. It's kind of it's true, and there's also a little bit of myth involved, but we'll cover that. One thing that I picked up is that the in order of operations, the idea of the exponents being solved first is common across all nations. However, there are some places, Kenya in particular, I guess, where students are taught that division is to be solved before multiplication. And a lot of people might find that shocking and, going against how everything should work, but you got to look at it and go, well, does it really change the result? If somebody was to tell you if division comes first, does it really change anything? That's the important thing. So, the article used an example similar to this. I'm using a little different example, but 200 times 40 divided by 5, okay? In the United States, it would be solved as 200 times 40 because you do multiplication and division left to right. So 200 times 40 is 8,000, and then you would take 8,000 and divide it by 5 and get 1,600. Now, if you use the Kenyan method, where you say division comes first, all right, 40 divided by 8 will give you um, yeah, 40 divided by 8, and then, um, I'm sorry, yeah, 40 divided by 5 is 8. I got that written wrong here, but 40 divided by 5 is 8. Then 200 times 8 is 1,600. So what you'll notice is you'll get the same answer. Many people won't believe it. They're going to have a disbelief, but please try a few examples and see for yourself. Either method is an accurate description describing the same step of order of operation. So whether you say do multiplication division left to right or whether you say solve the division first, you're going to get the same answer. And so I challenge you to try some other problems like this. And again, I apologize. That last area there, it should have been 40 divided by 5 equals 8, and then 200 times 8 is 1,600. So I got a little typo there. So how would you go about figuring out, well, what do you mean divisions first? I thought you just got done telling me that everywhere in the world multiplication and division have equal precedence. Well, consider how the problem could get rewritten and mean the same thing. Let's analyze it, okay? That's what this is all about. It's not about just following something blindly. So if you understand that division is just the multiplication of a reciprocal, you can take 200 times 40 divided by 5 and make it identical. You can take the 5, and we talked about this before, 200 times 40 times 1/5. So now you've made it all multiplication because multiplying by 1/5 is the same as dividing by 5. Now if you use the commutative property, which basically you want to look that up. But the order that you multiply numbers does not change the product. So if I go 200 times 40 times 1/5, that's equal to 1/5 times 40 times 200. The answer is going to be the same. Doesn't matter what order you multiply in. So already we're starting to say, well, maybe this thing they're doing in Kenya really isn't affecting the answer. And if you use the associative property, which basically means if you take when more than two numbers are added or multiplied, in this case multiplied, the result remains the same. So I could put parentheses around 200 times 40, like I show here. And on the other side, I could put parentheses around the 40 times 1/5. It doesn't change anything. And I see people mess this up too because they get confused. As soon as they see the parentheses, they're like, oh, wait a minute, you added parentheses. Those weren't there. oh my God, you changed the problem. But if you understand order of operations, and that's what it's all about, understanding the concepts, okay, concepts, you realize that I could put 20 nested parentheses around each of those multiplications, and it doesn't change a thing because multiplication already has its precedence, right? So all that's saying is, okay, I would go 200 times 40, get a result, and then multiply it by 1/5. And on the right side there, you would say, well, I'm going to take 40 times 1/5 in parentheses, and then multiply it by the 200. Thing is, you're going to get the same answer, okay? So that's one way to see how the Kenyan system really ends up giving you the same answer. So it really, it shouldn't be too surprising that people really get confused over order of operations. I see there's problems that people encounter, which I can't really go into here. I'm going to try to put some links to those other videos that I have. But people are constantly showing each other the results of their calculators, but unless you're using a scientific calculator, and I mean, if you're using a Windows 10, a Windows 7, maybe Windows 11 PC, the built-in calculator app typically defaults where what they call standard mode. You can also put it in scientific mode. You want scientific mode if you're going to do this, because in standard mode, basically the calculator is acting like something you would buy from the dollar store. It only can memorize one um, operation. It only remembers the last operation that it did. So it has very, very short-term memory. So what's going to happen is if you enter certain problems in there, you're going to get a different result. And I see people going, well, look, this proves my answer because it's this, which, really just they kind of end up looking silly because they're using a standard calculator. So the standard mode calculator on a PC is basically like hitting the equal sign after every operation. So, if I was to go back like a problem here, like 200 times 40 divided by 5, what it does is it goes 200 times 40 equals, and then you get a result, and then so on. And then it's just hitting the equal sign after every operation. So, uh, a lot of people still falsely believe also that any number multiplied by zero gives you the same number. Yeah, I'll hear people say, look, if I have, 10 oranges and I multiply those 10 oranges by zero, I still got my 10 oranges. So, they're basically describing addition but not multiplication. Their concept there is off. So I can't really go into all that here, but I have a lot more info. I've got some other videos that hopefully try to help things out. I have some videos that go into specific puzzles, especially a lot of the viral ones that are on the internet. But I'm trying to get more into concepts rather than individual puzzles because everybody wants the answer to a puzzle, but then they never understand the reason why. And if you understood the reason why, none of these puzzles would be hard. You would just go, oh, yeah, I know that concept. I know the answer. So, anyhow, we're going to hopefully dive into that more, but I think this video's gone on quite long enough for now. So, we're going to call it a day.